Hello, here are the video tutorial for 4.4 solving a square root equation. Okay, so we've done a lot of simplifying with square roots and numbers and maybe a little bit of variables, but this is about what happens if you solve for a variable within square roots. Like this is just kind of the methods of doing that. All right, squaring and square roots are opposite of each other, really opposite of each other. They cancel each other. They actually like cancel each other out, essentially. Like they give examples here. What if I square? The little 2 means squaring. What if I square the square root of 15? It becomes 15. That's just what happens. They cancel each other out. Um, yeah. So we will square. No, what are we gonna do? We will cancel out square roots of equations. I actually don't know what to fill in those notes. That I almost cross it out in class. Let's just move on to actually doing it. Yeah, so we're going to isolate. We're going to get the square roots by itself. Okay, so that's one thing you have to do is you have to make like the square root be by itself on one side of the equation. We'll get the square root kind of on one side of the equation. And again, it can be on both sides, but like as long as like on one side of the equation there is just a root, okay? Like it'll make more sense once we actually do this. And you square both sides to cancel out the square root. That's what number 2 is. Okay, so here's these examples. All right, so here we have x plus 4, square root of x plus 4 equals 3. All right, so we have the square root all by itself on one side, the equal sign, the other side, there are no square roots or anything. So what we can do is we would square both sides. Like you would actually like, what I mean is it's kind of hard to do this via Desmos, but all right, so this is like what the question says, right? All right, so in order to, first up, you want to cancel out the square root symbol. The way you cancel out the square root symbol is you square both sides, meaning now this is like that. And so by square rooting this, that actually makes the square root symbol cancel out. It goes away. And then you get the square root of, then you have to square the 3, which is 3 times 3, that's 9. And then you would subtract 4 from both sides, and x is 5. Like that's how you would do number 1. Okay. Now, as for the second example, okay, the second example looks like, just get rid of these. All right, notice they put a 5 here. Okay. They put minus 7 here. Okay. So in this example, okay, I gotta make the square root thing be by itself. Oh, it's plus 1. Okay. So I have to get rid of this 5 and I have to get rid of the 7. Now, in order to do this, we got to kind of go the opposite of order of operations. So I would add 7 to both sides to get rid of the minus 7 first. And by adding 7 to both sides, that makes the question now say 5 red x plus 1 equals 10. Okay, because I added 7 to both sides. 3 plus 7 is 10. All right. Now I need to get rid of the 5 because I want to isolate the square root thing on one side of the equal sign. So by getting rid of the 5, that's dividing by 5 on both sides. And by dividing by 5 on both sides, I now have this equals 2. All right, now we have the square root isolated on one side of the equal sign. Now I square everything. By squaring both sides, like if I were to square this, that makes the square root symbol go away. And 2 to the power of 2 is 2 times 2, that's 4. And then you would subtract 1 from both sides, and the answer is 3. Yeah, that's how to do that. Now, you can also do it like this. If both sides have square roots, you can have square roots on both sides. The equal sign, I'm just rewriting what that third example is saying. And okay, so in the first two examples, we just had a square root on one side of the equal sign, and once you isolate it on that side, you can square root everything. This is also true if there are square roots on both sides. Like if both sides have square roots, and they're both isolated, there's no numbers or weird things around it, you can square root it. Okay, so you can square them. So if you square both sides, if you square the left side, the square root symbol disappears. If you square the right side, the square root symbol disappears. And you get this. And now you have an easy solve for x problem. Like you would subtract x from both sides. You would subtract 1 from both sides, and x is -6. Now, there's a problem with that. Well, no, that's fine. That's fine. There's no problem with that. Yeah, okay, so that's how you do that. That's how you do these. That's how you do all these problems. Okay. Those are all pretty not too bad. It's not too bad. Okay, so something else that we want you to understand is, well, why? Okay, this is kind of a reason, like, why does, okay, why does, I mean, and a lot of you probably don't, are like, what, wait, why the heck, if I put a little 2 to the upper left of this check mark symbol, why did they cancel out? Why does this make that happen? Like, why does that happen? Like, why are they equal, right? Well, here's why. This symbol, the radical symbol, the square root symbol, also can be represented as an exponent. You can also represent square root symbol as to the power of a half. Okay, so you can actually have exponents that are fractions. And when you have fractions, that means there's roots. We'll get more into that later in the year, I think. So in other words, like the square root of 16 is actually the same thing as square root to the power of a half. That is what it is. I mean, for example, if you were to actually put into a calculator, like you should know by now that square root of 16 is 4. So if you put in like 16 to the power of a half, it's also 4 because this is the same thing as the square root of 16. So the reason why I'm saying this is because some of these problems don't say square root, instead they say power of a half. And so now the reason why this is true is that when you have, okay, so the reason why this is true is that, all right, so imagine instead of it being, okay, I'm going to take away the square root symbol, okay? How about instead of square root symbol, I put the half? Now, something that I kind of regret not teaching you before this unit that I'm going to teach you in the spring is about exponent rules. Now, when you have, this is like there's an exponent here, like this half is an exponent, and you have a 2 here that's an exponent. Like, so we have an exponent of an exponent. Like, what is the relationship between the half and the 2? Like, what do you do with the half and the 2? In this specific situation, where this 2 would be called a power of a power, meaning it's like an exponent of this thing and has an exponent, you multiply. You actually multiply the half times the 2, and half of 2 is 1. Like it is. Like you do 2 over 2, and 2 over 2 becomes 1. Okay, so that is why that when you you square root, you have a square root of something, and this isn't working very well for me. Like if you square root something like x plus 2 and you square it, it becomes just what it is, because what this is x plus 2 is x plus 2 to the power of 1, okay? That's what it is. So like this means x plus 2 to the power of a half. That's what this is. And then times 2, the half times 2 becomes 1. And that's why the square root symbol disappears when you square it. Okay, so go into like doing some questions like this one. I'm doing 11 because 11 actually involves some stuff that's interesting to me. Okay, so 20 minus r to the power of a half equals r. So what you do is you would square both sides. So I'm going to just rewrite the question. Let's see, minus r power of a half equals r. Okay, so if you have this, you would square both sides. So that means the r gets squared, and this other side, all that gets squared too. And then, so then notice like a half times 2 is 1. So the 20 minus r to the power of 1 is just 20 minus r. And that would equal r power 2. Okay, now if you look at this, what we have now, does anybody see how to do it? What to do now? Now, I'm going to show you is that, well, I want to make all of this stuff be on the same side of the equal sign, but I want to make the r squared stay positive. I want to make the r squared. So what I'm going to do is I'm going to subtract 20 from both sides, and I'm subtract negative r from both sides, which really means I'm adding r. So that becomes r squared plus r minus 20. Now that's what happens when I'd add r. So what's left on the left side of the equal sign would be 0. So I subtract r from both sides, I get minus 20. I add r to both sides, I get plus r. I have this. Now, if you look at this should look familiar to you. This is a factoring question now. Okay, and also it looks a little weird to say 0 equals, so I'm going to make it say equals 0. Oh, equals 0. All right, so you want to find factors of negative 20 that add up to 1. That would be 5 and negative 4. Those multiplied become negative 20, but they also add up to 1. Now 1. And so now I can do, just the short-term version is, okay, now I got r plus 5 times r minus 4 equals 0. And now you have that. You have that, and then via that, you now have two problems. R plus 5 equals 0, r is negative 5. And then r minus 5 equals, r minus 4 equals 0, r is 4. So this actually gives you two answers. Yeah, it does. All right, that's pretty hard. These 12 is easier. 13 is just like what I did, but they kept the square root symbol in there, which is not that hard, I don't think. Here's these. All right, the warm up, I didn't talk about that yet, but these are all kind of reviews of things we've done in the past, in the last couple weeks. And that's it. Yeah, so give this a shot. Yeah, actually, let me show you 16. 16 is kind of different too. All right, so for 16, you would square both sides, and by squaring both sides, you'd have 2v minus 7. The square root symbol disappears. But what happens over here? I got v minus 3 to the power of 2. Okay, so that means 2v minus 7 equals v power 2 minus, okay, for the sake of time, 6v plus 9. Like if you actually do v minus 3 times v minus 3, you get this. And then you want to make them all be on one side of the equal sign, so the v squared doesn't change. I would subtract 2v from both sides, and that becomes minus 8v because negative 6v minus 2v is negative 8v. And then I would add 7 to both sides, and that actually creates 16 equals 0. And now if you factor the factors of 16 that add up to negative 8 are negative 4 and negative 4, so this actually creates v minus 4 times v minus 4 equals 0. And, well, they both say v minus 4, therefore the answer is 4 for number 16. Yeah. Okay, that's it. I hope this is helpful. Have a good day.